In this video, we're going to continue with differentiation, and we're going to look at maximum and minimum values of functions. So given any curve, we can find the maximum and minimum values. So let's look at what that actually means, folks. So say I give you this curve here, we can see it's a cubic function. It has two turning points, and we can see firstly that it's increasing. It gets to the turning point, it then begins to decrease, another turning point, and it increases again. Now, I said firstly that the curve was increasing. Where is that increasing from? So it's actually increasing from its minimum value, which is negative infinity. Now, after this turning point, I said that the graph was increasing, and that will basically go on forever. So the maximum value of that curve is positive infinity. Now, I didn't have any bounds on this. I basically found the maximum and minimum values for x between negative infinity and positive infinity. So what if this time I want to find the maximum and minimum values of this same graph, but this time I've created intervals. So I basically want to find the maximum and minimum values of that graph between these two lines. Okay, so you can see that the maximum value still increasing. It's going to go quite a long way before these two, before the curve and this bound, before that meets. So we'll still say that the maximum value is infinity here. However, the minimum value has changed because we said it was negative infinity way down here, but in actual fact that's out with our bound. So you can see that the minimum value is here. So this point that I've put on, the minimum value will be the y value, the y ordinate of this point. Now, what if I change this further? So I've made the interval even smaller here. And hopefully you can see the minimum value, I've left that the same as the previous one. So it's the y ordinate of this point. Now, the maximum value previously was positive infinity because the graph went away off up here and it continued increasing up to positive infinity. But this time actually, if we look across here, the highest point between these two lines is here. So it's the maximum value is the y ordinate of the turning point here. So you can see that we've got a variety of things going on here. Here we actually had the minimum value, and here, being sort of endpoints of the curve within the given interval. And here, the maximum value happened to be a turning point. Had we moved this line even further in, the minimum value might have been here. It might have actually been the other turning point. So it's just something that we have to investigate for every different curve that we meet. So in a closed interval, the maximum and minimum values of a function are either at a stationary point or at an end point of the interval. So let's have a look at maximum and minimum points. So we want to find the maximum and minimum values of y equals 4x cubed minus x squared minus 4x plus 1 in the closed interval x lying between negative 2 and 2. So the solution then, we have our original equation of the curve, and we're firstly going to look at the endpoints. So the endpoints are the endpoints of the interval that we're dealing with. So we're firstly going to look at when x is equal to negative 2 from here. So we take our equation and we substitute negative 2 in there. So where there's an x, we're substituting in negative 2. So 4 multiplied by negative 2 all cubed minus negative 2 squared minus 4 times negative 2 plus 1. And when we calculate that, we get y equals negative 27, which corresponds to the point -2, -27. Now, so that's the end point at the left-hand side of the interval. We now need to find the end point at the right-hand side. So the other side is when x is equal to 2. We've got x equals 2 here, and we're substituting x equals 2 into that equation. So y equals 4 times 2 cubed minus 2 squared minus 4 times 2 plus 1. And that gives us y equals 21 and corresponds to the point 221. So we've found both the endpoints, and this time we need to investigate the stationary points. So we know that stationary points occur, to find stationary points we look for the derivative. So dy by dx is 12x squared, that comes from the 4x cubed, minus 2x, that comes from the minus x squared, and minus 4, and that comes from the minus 4x. So we know that stationary points occur when dy by dx is equal to 0, because the gradient of stationary points is 0 and dy by dx is also the gradient. So that means that 12x squared minus 2x minus 4 is equal to 0. Now I can divide through by 2 here, and hopefully that makes factorising slightly easier. So when I divide through by 2, I get 6x squared minus x minus 2. Factorising gives me 3x minus 2 multiplied by 2x plus 1 equals 0. And from that first bracket I get x equals 2/3, and the second bracket x equals negative a half. Now in order to find the y ordinates of the stationary points, I need to take each of these, x equals 2/3 and x equals negative a half, and substitute them back into the original equation so that I get y. So when I do that, I get 2/3 negative 25 over 27 and negative a half 9/4. So I now have all the points in question that could contribute to the maximum and minimum values of this curve, and I've looked for these within the closed interval -2 up to 2. So what I do need to check with my stationary points as well is that the x values of my stationary points actually occur within this interval as well. Now in this example they do, but say this 2/3 was 5, for instance, so x equals 5, well we can discard that point because it's not within this interval. So you just need to be aware of that as well, folks. So the maximum and minimum values, I want to look at the 4 y values that I've got. And when I examine the 4 y values there, I can see that the minimum value, the lowest one, is -27. And that occurs when x is equal to -2. Now, if I look for the highest y value, the highest number there is 21. So that's a maximum value. And that occurs when x is equal to 2. So those are my minimum and maximum values. And I can just check that using my graph. So you can see here that between -2 and 2, all the way down to -27, you can see my 2 stationary points here, and you can see that I've got the point 221 at the end of the interval. So you can see that that is my minimum value down here at -27 and my maximum value here at 21. So just now would be a good time to pause the video before the screen goes blank and copy this down in your notes.